Japan uses casting method to create durable propellers. Workers start by mixing sand in a container and then pouring the sand into a mold box. After the mold is filled, the sprue is removed and the model is finely detailed with a knife to achieve a perfect state. Then, a spray gun is used to heat and harden the model. Next, lifting tools are used to flip the mold box, merging the two halves to form a complete propeller casting model. Once the model is ready, workers connect a gas device to the furnace and ignite it for preheating. Once preheated, brass ingots are placed into the furnace to melt. Workers remain by the furnace, continuously skimming off impurities to ensure the purity of the molten brass. After melting, the molten brass is transferred to the pouring station using a crane. The technician tilts the furnace, allowing the molten brass to flow into a crucible. Once the crucible is filled, it is moved over the casting model, and the molten brass is poured into the mold. During pouring, the surface oxidation is skimmed to avoid air pockets. After pouring, the casting is left to cool naturally to room temperature. Once cooled, a crane lifts the mold, and the propeller is carefully extracted. High-pressure air is used to clean off any remaining sand from the blades, and steel brushes are used for detailed cleaning in hard-to-reach areas. The clean propeller is then weighed on a platform scale. Next, a cutting machine is used to trim the base of the sprue, followed by hammering off any excess material. Dust-free grinding wheels are employed to smooth the edges, with the built-in vacuum system collecting metal dust for safety and environmental purposes. The propeller is transferred to a lathe for machining. Horizontal cutting tools remove the propeller's top section, followed by the machining of the taper surface of the shaft hole. After machining, the propeller is placed on a CNC milling machine to engrave helical lines on the blade surfaces, reducing cavitation during high-speed rotation and enhancing durability. After engraving, the blades are polished to a golden sheen, resembling a work of art. The propeller is then placed on a dynamic balancing machine to ensure even rotation. The propeller is moved to a precision workshop for a thorough 360-degree polishing. These grooves not only improve aesthetics, but also reduce water resistance, enhance fuel efficiency, and increase the ship's speed. Finally, a metal flaw detector checks for any internal cracks or defects. Once it passes inspection, the propeller is complete. How would you rate this craftsmanship?